Known as the theme park capital of the world, Orlando is a beacon of ingenuity, creativity, and advancements in technology in the area of themed entertainment. With the passion for engineering and themed entertainment blossoming on this campus, the idea to apply that knowledge to the university's beloved mascot Knightro was soon born into what would become the Bring Knightro to Life BK2L Project Series.
The BK2L 1.0 team was a mechanical and electrical engineering team. They were tasked with creating an animatronic of Knightro, but they ran into difficulty with producing the interactive code. The BK2L 2.0 team was a computer science team. They were tasked with creating a code interface capable of interactability and extendability. The goal of the BK2L 3.0 project is to create a new iteration of the 1.0 figure that improves its proportions, range of motion, and fluidity of motion. While the original figure is impressive, it did not accurately represent the shapes of Knightro's armor. The figure did not have the ability to make expressions, and many of the pieces were attached loosely and were unsecured. In this iteration, we hope to capture Knightro's energy and charisma. We were able to take the spirit of the code from the 2.0 team's project to create our own version that utilizes the newly released ChatGPT to act as our database and response system.
On the project level, our goal was to integrate any lessons learned from the 1.0 and 2.0 teams, as well as combine the physical figure from 1.0 and the code created in 2.0. To do this, we improved upon the mechanical and hardware features of the 1.0 iteration by increasing the number of degrees of freedom and by creating less spastic motion. Also, elements of the 2.0 iteration's code and software were implemented in this 3.0 iteration to allow the figure to pull data from the internet and communicate with the user. On the university level, the team was tasked with creating a more proportional and visually stimulating Knightro compared to the 1.0 iteration. By using 3D scans of the Knightro costume, this objective was achievable through the use of CAD and 3D printing. On the industry level, the main objective was for the Knightro animated figure to be an attraction for other students and faculty. With the improved movement, interactivity, and with the voice of the Marching Knights Jason Millhouse, this 3.0 iteration can be placed in the engineering atrium on campus to be enjoyed by all Knight fans. Along with the different levels of objectives, the 3.0 team also had generic functional requirements for this to be considered a successful engineering project. These are to design and build a skeletal structure capable of supporting 20 pounds, reliably start, stop, and interact with users, have the figure be capable of performing the UCF chant, communicate to the user through audible means and utilize the internet to find up-to-date information, and design a model that is scaled to accurately represent the official UCF Knightro mascot.
And now, let's meet the BK2L 3.0 team. Hey, my name is Rachel Christie, and I was the figure finish, parts procurement, and collaboration contact lead. My primary responsibilities were to assess brand recognizability, complete all purchase and checkout orders, create the non-3D printed wardrobe, and serve as the primary contact for external collaborators. Alongside other team members, I worked on sanding, painting, and magnetizing the armor, as well as determining armor placement to avoid any collisions.
Hi, I'm Eric, and I was our controls engineer. I was responsible for writing all our code, programming the motors, and integrating all the interactive elements that bring him to life. I also completed the 3D scan of our source material.
Hi, I'm Neil Califf. I'm a mechanical engineering major and theater minor. I helped with armor modeling and figure animation for this project. I created preliminary models of the armor based on the 3D scans. I helped with animating motion sequences for the figure and coordinating the 3D printing of all the armor pieces, in addition to sanding and painting and finishing all the armor pieces. I also helped with assembly and wire management for the final figure.
My name is Sarah Parsons, and I'm a mechanical engineering and studio art double major. I was the armor modeling and eye animation lead. My primary responsibilities were creating final models of the armor and creating expressions for digital eyes of the design. I also helped with sanding and painting armor, and I assisted in animating the figure.
Hi, my name is Alexis Popel, and I was the Structural Analysis and Preliminary Design Lead. My main responsibilities were to create preliminary models and a proof of concept interactive code, create the FMEA, perform stress simulations to assess the design, and secure the team workshop location and ensured it had 24/7 access. Along with other members of my team, I helped sand, prime, and paint the armor, as well as helped assemble the final model.
Hi, my name is Ryan Sternbecke, and I was a lead mechanical designer on the Bring Knightro to Life 3.0 project. My primary responsibilities included designing and modeling the internal mechanical system of our figure, while also performing the motor torque and electrical calculations to ensure our motors and our electrical system supported our needs. Additionally, I aided in our figure's 3D printing manufacturing process, as well as the finalization of our motor configurations, electrical wiring, character animation rigging, and figure animation.
It was really important to us to create the most accurate figure possible, so who better to get proportions from than the real Knightro? Using a free phone app called Polycam and an iPhone 13 Pro, we took multiple laser scans of Knightro so we have the most accurate source material possible. These scans were then exported into Blender and SOLIDWORKS for creating armor and the internal structure respectively.
To begin modeling the armor pieces, we imported the Polycam 3D scans into Blender and used them as a base to sculpt the armor pieces around. These preliminary models were tweaked and polished into the final models we used for the figure itself.
Functionality was a priority in our design. We wanted easy access to internal components, so we designed a removable panel at the back of the helmet. Magnets connect the pieces, while a locking mechanism ensures a secure fit during dynamic animations.
For our final model, the scale of our figure was depicted by the size of our hand, which was the smallest mechanical assembly. The hand was designed using linear microservomotors to actuate the linkage system for each finger. The hand was attached to a 2 degrees of freedom motion system utilizing a universal joint to pivot the system upon. A third motor then rotates the system via direct drive to complete the 3 degrees of freedom required for the wrist movement. Moving up the arm, the elbow function is achieved using a 4-bar linkage configuration, which is then attached to a 3 degrees of freedom direct drive shoulder. This arm is then mirrored across to create our second arm. The neck movement is achieved using a reconfigured version of the wrist mechanism to drive the head in 3 degrees of freedom. In order to achieve the required torque of the torso bending function, a 3-to-1 planetary gearbox is used in configuration with a 45 kilogram motor. In a similar manner, the torso rotation function is created through a 2-to-1 gear ratio to provide smooth and controllable movement of our figure. Finally, these components were modeled specifically to be 3D printed and assembled easily using brass thread inserts and a variety of fasteners.
The first version of Knightro did not have any capability for facial expressions. The eyes of the 1.0 project consisted of a piece of cloth inside of their helmet. We decided to improve on this by giving Knightro eyes that were animated on a flexible LED matrix. The flexible screen allowed us to follow the contour of the helmet and give Knightro an expression from both the fronts and the sides. Although Knightro's expressions are limited, since he doesn't have a mouth, this method provides the ability to integrate any shape of eyes and express a wide range of emotions.
While Knightro canonically does not speak, the team felt that giving him a voice allowed for the greatest level of interactivity and was in line with the 1.0 and 2.0 designs. Jason Milhouse, the voice of the university's Marching Knights, lent his vocal talents to the cause, making our favorite knight sound as regal yet fun as he acts.
Once our pieces were 3D printed, the team sanded each piece with an increasingly fine range of sandpaper in order to smooth them out as much as possible. Filler putty was used to fill any gaps, and the pieces were primed and painted gold until they looked just like Knightro.
Assembly of the figure took about 2 weeks and involved 2 phases, mechanical and electrical. Mechanical components were first assembled separately and then placed onto the base. Once done, wires were routed from the fuse block and control boxes in our base frame up to the motors and screen. Ethernet cables were also routed for connecting the Pi to the Waggle Pro IOs.
In order to help Nitro's mobility, some of his armor pieces were patterned and sewn to fit him just right. These pieces were made of a stretch fabric, stuffed with quilting batting, and placed at high traffic motion locations to provide a cushion between printed parts. Nitro's iconic cape was a necessity and of course was included.
Hey Nitro,
Hey, Night Fan. What can I help you with?
who are you?
I am the one, the only Nitro.
Okay, that was smile for everything.